Hey, 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 young scholars. This week, right before spring break, I know you're excited and waiting to be off again with lights and water this time. We're going to review simplifying radicals, go over multiplying and dividing the radicals, just so that it will prepare us for the Pythagorean theorem. For this week, we'll do the Pythagorean theorem, Pythagorean triples, and application of both. Okay, but in order to be successful with the Pythagorean theorem and the Pythagorean triples, you will need to know how to work with radicals and become familiar with them. I know that some of you have been overlooking it, just trying to use a calculator, and I do want you to use a calculator to simplify. So let's just go ahead and dive on into it. All right, now how do we know when a radical is in its simplest form? Well, we need to check. Right now, we just want to see if a perfect square can be divided evenly into the radicand. Later, we'll be interested to know that radicals should not have denominators, and the radicand has no fractions. Shouldn't have a radical in the denominator. Okay, here's a list of perfect squares. I need you to keep this list somewhere in your brain, preferably, but if you need to write them down, because these are the numbers that we need to use to divide into our given radicand to see how we break it down. Okay, now sometimes you don't have to break it down. Sometimes your radicand can be a perfect square. For example, this is asking us to take the square root of 49. But when we look at our perfect squares, we have 49, and we notice that it is 7 squared. So therefore, our answer is 7. Real easy. Okay, then we have the square root of 25. 25. That's 5 squared. So our answer is 5. Here our radicand is 121. Find 121. Square root of 121 is 11. So really, really easy when our radicand are perfect squares. Now there are times when the radicand is not a perfect square. Okay, and it's these problems. And these problems, you will be able to find these problems on your in Canvas. Okay, so we'll take a look at those right quick. Okay, in Canvas, if you would just go to your modules, go down to your right triangles, practice on simplifying radicals. Go ahead and press that, and we're going to practice, and I am going to go over a couple of these problems with you. Remember, guys, I'm not trying to make it difficult, but you are, and you do need to show your work. When you show your work, then I can look through to see if there's an error. Just like the problem that we worked dealing with the Pythagorean theorem, there was an error there. Okay, and because I showed work, then I knew where the error is, and I know how to address those areas that are difficult or that causes you problems. Okay, so in the student view, you just go and submit your assignment, and then we're going to go down. I'm going to go over. Well, let's just take a look at number 1. Number 1 is done for you. Remember, we go ahead and write our problem, the square root of 32, and then we look through to see which one of our perfect squares, which one of these perfect squares will divide evenly into 32? Okay. You also have this online calculator there. So we'll take the radicand, which is 32, and we're going to divide. We can start with, we don't think 25, but we can start with 25 just in case. Some of us understand. Okay, that's not going to work because we have a decimal, and then we can move to 16. So we have 32 divided by 16. All right, look, we get a whole number. So once we have a whole number, then we know that we have a perfect square. So the two numbers, 2 and 16, we break up our radical. Square root of 16 times the square root of 2. And then we simplify it. 16, square root of 16 is 4. So we bring the 4 out. What's missing? Square root of 2, that 2 has to stay there. So our answer is 4 square roots of 2. Okay. All right, now, how did we get that in there? Well, we used our text entry. I'm going to do number 2 with you. 2 is 5 square roots of 12. Okay, so we go into three dots. We go down to the square root symbol. That's where you insert math equations. Since we're doing number 2, we're going to put 2 here. And short-term memory. Okay, 5 square roots of 12. And I want to do that one. Let's go to number, but we'll do 2. 5 square roots of 12. So we do the 5 square root of 12 is equal to, and we have to, whatever's on the outside stays on the outside. And what we're going to do is we're going to, anything that's out there we multiply. Okay, times the square root of 12, and then 12, we can break down 12. Okay, we have 12. We could divide it by 9. Okay, let's go ahead and try that. Don't forget to clear. 12 divided by 9 doesn't work. Okay, then the 2 times 2, 12 divided by 4, and we get 3. Okay, so 4 and 3, though that's what goes underneath the radical. Those two numbers. That happens to be my dog is snoring. Okay, the square root of 4 times square root of 3 is equal to, now remember the 5 stays out and we multiply. We're going to take the square root of 4, that simplifies to 2, so we're going to multiply the 5 and the 2 eventually, but then we need to make sure that we take care of that square root of 3. Can't simplify that, doesn't have a perfect square in it. Okay, so now we're just looking at this part here. 5 times 2 gives us 10, and square root of 3 is left. And there you go. Simple. Okay, and then you just insert. All right, so that was number 2. Let's try a bigger one. Let's try number 4. Number 4 is 6 square roots of 120. Let's go to this equation editor. That'll help. 4 is 6 square roots of 120. Okay, now once again we know that the 6 stays out, and we're going to multiply it to whatever we break it down. So we're looking for a perfect square that will go evenly with into 120. So I'm going to bring back up the calculator. All right. Let's take a look at these just in case. Okay, so we have 120. 120 is our number that we're starting with. We can start with 100, 81. We know that that's not, we don't have anything. We can start with 64. That's an even number. Let's go ahead and try that. Let's just start with 64. Now, some of you could probably guess it from the very beginning, but we want to show you just in case you can't see it and you don't want to waste time doing a lot of stuff. Okay, so we're going to put the radicand, which is 120, and we're going to divide the 64. Okay, that doesn't give it to us. Okay, so now we'll go to the 49. Clear it. 120 divided by 49. Okay, that's not getting it. Clear it. 36. 120. And like I said, you don't have to go through all of those if you have some idea. Okay, that doesn't work. And then let's try 25. Sometimes it just takes a little effort. It might take you a little bit longer than usual, but we're going to get this right. We're using the calculator. Okay, so that's 4.8, so that doesn't work. Clear it. Let's try it again. We had 25. Now we're going to start. Now we're going to try 16 divided by. Not sure if I did that. Okay, so that doesn't work. Clear it again. Let's go with 9. See, it just takes a little bit extra just to get it right. Okay, that doesn't work even though it's 1,000. Still doesn't work. 120 divided by 4. Uh-oh, last one. Oh, look at that. 30. That one works. So we have 4 square roots of 4 times square roots of 30. That's how we break down 120. 120 is broken down as 4 and 30. 4 is our perfect square. Okay. So let's go and let's enter that. So we'll have 4 here. And then we need another one times the square root of 30. Okay, now we're going to keep our 6 out, multiply that times square root of 4, which is 2, and then we have our square root of 30. Still not finished, but almost. Sometimes it just takes a little bit longer. 6 times 2 is 12, square root of 30. Voila, and there's our answer. Okay, don't forget to insert. All right, and if you need to put in 1, don't forget to put in 1 or 3. You just let's see if it'll. Okay, just enter, and you can make your spaces. Okay, so for the next 5 minutes, if you would go ahead and complete that. After 5 minutes, then we will go into our Pythagorean theorem. I'll be here. Good luck, and see you in 5.